In section 1, we learned vertex form of the quadratic function and how closely related vertex form is to all of the transformations that we already know. Section 2, we are going to learn a new form of a quadratic function, which some of you guys may recognize this from Algebra 1, standard form of a quadratic function. So first of all, let's compare to vertex form. Vertex form is y equals a times x minus h squared plus k. And remember that h and k tell us the vertex. It's really, really helpful information to know. Standard form still can tell us some helpful information. We just don't see the vertex right away. Standard form for a quadratic function is y equals ax squared plus bx plus c. Notice how we don't have any parentheses there. We don't have a quantity that's squared. All of that multiplication has already been done for us. So we could get from vertex form to standard form if we multiplied this binomial. All right, so here's standard form. Like I mentioned, we don't see our vertex right away in standard form, but some things that we can see, just like before, our a value is the same. So a can tell us if your parabola opens up or down. And again, it's the same a value as we see in vertex form. Okay, we can find our vertex though. The x coordinate of our vertex is negative b over 2a. And if we know the x coordinate of our vertex, we can plug that in to find the y coordinate. Of our vertex. All right, so here's our general information about our standard form, and let's get working with it. Here is example 1a. Let's find the vertex, the axis of symmetry, the maximum or minimum value, the domain, and the range of our function y equals 2x squared plus 8x minus 2. All right, well, I'm going to list out all of this information we need to find, just so I don't forget to find anything along the way. Our vertex, axis of symmetry, and I'm going to leave a blank here because I don't know yet if this is going to be a maximum or a minimum. Our domain, and range. I'll just put that maximum in for now. Okay, first thing we probably need to do is to figure out our vertex, and everything else will kind of fall into place from there. Negative b over 2a tells us the x coordinate of our vertex. I'm looking at my equation here, looking at my function. A is always going to be attached to my x squared term. B is always going to be attached to my x term, and then c is my number at the end. Okay. So my x coordinate equals negative b, we said was 8, over 2a, the number in front of the x squared term. And that's negative 8 over 2 times 2 is 4. Negative 8 over 4 is negative 2. That's the x-coordinate of my vertex. Plug it in to find the y-coordinate of our vertex. Plug this negative 2 in for x into my equation. Y equals 2 times negative 2 squared plus 8 times negative 2 minus 2. And we can work this out. Negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is minus 16 minus 2. Again, negative 10. So put this together. Negative 2, negative 10 is my vertex. The axis of symmetry is, remember, don't forget that's a line. X equals negative 2, the x-coordinate of my vertex. Now, does our parabola have a maximum or a minimum value? Look at our a value to figure out if our parabola is opening up or down. And since a is positive, that's my clue my parabola opens up. Here's my vertex, negative 2, negative 10. Just a quick little sketch of my parabola. Since my parabola opens up, this is the lowest point. We have a minimum value of negative 10. That's negative 10 is the lowest we go. Domain, that's my x values. We go to the left forever, we go to the right forever. My domain is all real numbers. And then range is my y values. Since this is a minimum, all my y values are above negative 10. Y is greater than or equal to negative 10 is my range. And one last thing that I didn't mention earlier, that I should have mentioned when I was listing out my general information here, the C value. C is going to tell us the y-intercept, and we'll see that in example 2. But C tells us the y-intercept of the parabola.